Hello guys, so welcome back to today's mathematics class for this upcoming WAEC and JAMB examination. So this class we are going to be dive into rules of differentiation. Okay, I know this is on a calculus, okay, but in this today we'll be talking about the rules of differentiation. Okay, what I have here by the end of this lesson, okay, by the end of this lesson, you'll be able to use the rules of differentiation to evaluate some different products, quotients of algebraic function. Okay, so guys, before I proceed into what we have for you today, so if you are watching my video for the first time or just visiting my YouTube channel for the first time, or Facebook page, Instagram page, and also TikTok and also Twitter. If you're watching this video at this moment, please do it to subscribe to our YouTube channel, give a like to this video, and share with your friend so they can benefit from this class. God bless you guys as you take 1 minute at a time to share this video with your friend. God bless you. I wish you more wisdom, knowledge, understanding, and success in this upcoming examination. A is a portion. 90 plus is the score in this upcoming JAMB examination. Believe that. But share this video with your friend so let them also benefit from this class. So for those of you if you wish to like the way I teach and you wish to join our Telegram, wish to join our WhatsApp group where you can interact with us, so you can join our members there. So just go to the comment section and ask for the link to join our WhatsApp group, so I can add this to our WhatsApp group. So that is our support group. In case you have anything to discuss about any mathematics, you can discuss with us there, and then we get back to you and we guide you how you can succeed in this upcoming examination. So for those of you that are coming to the class right for the group, you should know that the necessary material you need is a book, okay, and your pen, and then write your lesson notes. And it's very important to submit it. Okay, I do check it and see how far you have done with the class. So it's very important to submit your lesson notes. So let's see and let's dive into the beautiful word called rules of differentiation. Many of the students are finding it difficult to solve this topic. I said this topic is very difficult for them to solve, but at the end of this class you will learn because I'll break it down in the simplest way that you can understand it. Just watch to this video, to the end of this video. I can guarantee that 100% that you get everything you know about this differentiation, because I'm going to break it down step by step and use a very easy method for you to understand. If at all you don't like my mathematics, you definitely like this particular class I'm about to explain. This particular class, and just put it like that. Okay, let's dive to it. So we are discussing about differentiation. So how do you understand about something you have to differentiate? When you're talking about differentiation, we have different rules, and some people they group the rules, and there's those that group the rules in different way. We have three main rules of differentiation. The first one, it is called sign. So let me pick the pen out. It is called the first one is called sum and difference rules. Some of the rules we break it down as sum rules and difference rules, but this one they are still qualified into the same place. It's the same method, okay? And second one we have the chain rules, okay? And the last one we have the product and the coefficient and the quotient rules. This quotient rule that classify as a different. They make it as here we have 1, 2, 3, 4, 5. There's a bit classified as 5. But this rule I'm using in cosets. So in this way they classify it into 3 is product and quotient rules, okay? But in the rule they put the product rule because product has its own methodology, okay? And quotient has its own methodology, okay? So their general expression is different to each other. So that is why they may express it in that terms. So, and in this aspect, when I talk about chain rules, it's stand on its own. Sum and difference rules is also stand on its own. So these are the main rules we have in differentiation. I said that earlier that they classify into different way. So when you have the sum and difference, they are under the same, they have the same method, and we have this sign rule and the chain rules, they are different. Also what method has its own method. The product and the question, they have their own methods. So those are the things we'll be discussing under the rules of differentiation. We have the first one, sum and difference rules. The second one, chain rules. The third one, product and quotient rules. Now, but for today's video, for this particular video, we only be discussed on this first one, which is the sum and difference rules, for the sake of the length of this video, because I don't want too much. Okay, I don't want to be up to hour, to be up to like 20 minutes to 30 minutes like that. So I just want to make the video in short that you can watch it again and again, and you can watch it again and again, so you can able to understand it. So that is why I want to take it out the first rule. So the next video I'll discuss about the second rule, and the next video I'll discuss about the product rule and quotient rules. So that is how I will do it. And we have question. Now, you know me, whenever you come to class, you always know that after the class, I must give you classwork that you should test your knowledge. Maybe you have understand what I've taught you in the class. That is our teacher for that, and that is how it should be. So that is why I say that it is for if you are yet join my WhatsApp group, our support group, it is right time for you to join them. It is free, okay? And if you would like to join my VIP class, also you can request for it. I will add it to my VIP class. Now the way we treat the VIP class is so different for the free class. Okay, so let's dive into it. So let's discuss of this first rule, sum and difference rules. Before I discuss that, I would like you to cut your notice when you talk about differentiation. Differentiation has its own general form. Okay, when we are given a question, okay, of y, the general form of differentiation, when you give a question of y is equal to as with power of n. When you give this question here, we are told to find y is equal to as with power of n. Okay, in these aspects, so when you have a question like this, and the question says if you differentiate this y respect to s, so let's say we are differentiate this y respect to s. When I give you the question, sorry, what's happened? So when you're given a question that y is equal to as squared, okay, I mean as is part of n, when you're given an expression like this, so when you're told to differentiate it respect to s, in the general form of differentiation, this n, this power is called the index, and power we multiply by this constant, by this s, it's multiplied by this constant here. Is multiplied by the coefficient, the base here. Okay, then put that base. No, and in this is we have the base, we have the power. Okay, the power we multiply by the base, and then we subtract one from the power. So what I mean by that, this n we multiply by this base here, it will be equal to ans, because these n's are multiplied by this base here. That's why I write it as ans, or you can write it as nas. Anyhow you like, it's still the same thing. Now, you have to subtract 1 from this way, because the ratio means that we are subtracting, okay? You have minus 1 from the power. So this one means that we have our n minus 1. So when you differentiate this y respect to s, the answer is equal to this ans with power n minus 1. This will be the answer according to the expression and general form of differentiation. That is how you differentiate a given question, and it asks you to differentiate it. That is how you differentiate it. Now let's come to a situation whereby you want to discuss about the sum and difference rules. So let me put an expression. For example, when you're given an expression that we have a y, okay, y is equal to, let me use a u plus v. Okay, when we're given a question like this, y is equal to u plus v, and also if you have another question, or you have a question that you have y is equal to, what's happened to this thing, right? Okay, thing is the pen. So when you assume that we're given another question that y is equal to u minus v, this one is sum, while this one is what? Is difference. Difference means that it's subtraction, okay? That's the meaning of difference. So we're told to find to differentiate this. Let me try to create space. When you are told to differentiate this, expression here, this sum, okay, let me try to write it here. We have a y is equal to, that's u plus v, and you want to differentiate this in respect to y. Okay, we want to differentiate this in respect to s, rather. So we want to differentiate this question in respect to s. So that means we differentiate the y respect to the s. So d be equal to the y respect to s of this question, it will be equal to, that is d of this y, and this y is in different form. We have the u, we have the v, so it means that we differentiate this u respect to s. We have u plus u divided by respect to s plus so the same thing here. You also differentiate this of v respect to s. So that means that we have our dv divided by what? ds. Okay. So whenever I have an expression like this, that according to this sum rules is given that y, if y is equal to v u plus v, when I differentiate with respect to s, it will be equal to the v ds plus the u ds plus the v ds. Then when you differentiate it, it means that we differentiate this u respect to s, and also it means that we differentiate this v respect to s. Then you get the answer when you deal with what? Sign. I mean the sum of the sum rules. The same thing applicable to these different rules. So when you have a y equal to, that's u plus u minus v, at the same thing you can express it in this way. We're taught to find the y, okay, the s of this question. You can simply say that our d open bracket, we have u minus v close bracket divided by the s. So see the same thing as what I did here. So if you just open this bracket and all these two parts, they are sharing this d, they are exchanging this one, they share this one ds. So this one becomes that equal to, if you open this bracket, we have a du over ds plus minus, because I minus here, that's our dv divided by the s. So the expression of this question of the sign rules of the sum rules and the quotient rule, they almost the same. The difference is this one is, sum is plus, while different is negative. So that is why it is minus. So when you have an expression like this is how you solve it, and when you have an expression like this is how you solve it. So this is what is called what? This is called difference rules, and this is called what? Sum rules. So that is everything about, you should know about sum and difference rules. Now let's look for example. Let's use example to make it easy, to make the life more easy for us. So let's look at this example I have for you here. Look at this example I have for you here. So we have the example. So try to create a space. Okay, yeah, I think it's done. Yeah. So let's look at this example. The question said that find the y ds of the following. We have two examples here. So if you look at this, is a mission of positive for the sum and the negative what's the sum rules, and is a combination. Let me put it this way: is a combination of the sum rules and the difference rules. Okay, so that is why sum and difference rules, they are put in as one rules of differentiation. Now, how do you attend to this question? How do you solve this question? If you see this question in this upcoming WAEC examination, in this upcoming JAMB examination, how do you solve this question? How do you handle it? So according to what I've explained here, I think by now you should know how you can solve this problem. So let's dive into the solution of it. Now let's take the first question. Now I want to differentiate this in respect to what? So this is the y. I want to differentiate in respect to s. The question, let me read the question again. Find the y ds over of the following. We have y is equal to s to the power 4 plus 4s to the power 3 minus 2s plus 1. While the second one, we have a y is equal to 6s squared. Okay, 6s to the power 3 minus s squared minus 4s plus 1. Now let's break it down and let's solve it. So when it's in a question like this, example like this, it is called to solve a question like this, it is called sum or difference rules. This is an example under the sum and difference rules. That is how you identify that this question is from differentiation and this question is from sum and difference rules. So that is how you identify it. When it's in a question like this, it is under sum and difference rules. Note that, put that at the back of your mind. Now let's solve the first question here. We have our y, question A. We have a y is equal to, we have a s with power 4 plus we have 4s with power 3, okay, I have minus 2s plus 1. Now how do we differentiate this one with respect to s? According to what I expressed there, at this part here, so let me try to show you here. According to how I express this part, you should know that we have a du, the y ds is called du over this because we have, let me try to bring it out more. So you know that when you have a expression like this, when you differentiate this with respect to y, is given as du, you differentiate this u with respect to s, plus you differentiate this v with respect to what s, and then you get the answer. So this same thing applicable to what we are about to solve here. Now let's demonstrate. Now to differentiate this one with respect to s, it means that we have our du, our dy, ds, it will be equal to, so we have to differentiate this one with respect to what, to s, which means we have our d, I have d of s with power 4 divided by ds. So differentiate this one with respect to s, plus the same thing applicable here, we have d over 4 s with power of 3 divided by, that is the what, the s, okay, and the next one we have minus, that is d, that is 2s divided by what, the s. And the last one, let me try, maybe I can see space there. Yeah, there's still no small space there. So the last one, that is a plus, okay, we have plus, we have d, okay, the 1 over, that is the s. So I will explain something here. Listen to this, how I want to solve this. So let's for the first differentiate. Let me write this one here. We have, do a line. You have dy ds is equal to, so let's differentiate this one with respect to s, and s is equal to s with power of 4 here. According to the general form of this word differentiation, what I have here, the power here multiplied by the base, and subtract 1 for the power. So let's use it here. So when you differentiate this one with respect to s, and s is with power of 4 here, this 4 will comes here, okay, this 4 will come at this back here, so it becomes, that is 4, the 4 will come in, 4 multiplied by the base what is s, that is what is equal to 4s, and we subtract 1 for this 4, that is 4 minus 1, so the power will be subtracted by 1, okay. The first thing, the power will multiply by the base, which is that s, I will subtract 1 for the power, then we have differentiate this one. Now let's go to this part now. We have plus, okay, let's differentiate this with respect to this s, and here we have 3 here. 3 will multiply by this base here. That's here we have 4 there already. That is 4 multiplied by 3, okay, s, and s, subtract this 3, subtract 1 for this 3, that will be equal to 3 minus 1. So we have differentiated these parts. Now let's go to this part. So we have minus. So in this place now, we want to differentiate with respect to what? To s. Okay. So here now, this s here, it has a coefficient, it have an index here. The power of this s here is 1, which is not visible. So we can put it as 1 to make it easy. We have the power here, which is 1, because when you just have s, that s is raised to the power of 1, but that one does not visible. When something is raised to the power of 1, it does not what? Visible. So that is why this one does not visible. So it means that we have 1 here, 1 multiplied by the base here, that's 1 times 2 here, that's, let me write it as this as well, 2 multiplied by 1, okay, and also multiplied by what? S. Now let's subtract 1 from this what? Let's subtract 1 for this s here. So that means that 1 minus 1. I get now plus. In this plus now, this place does not have what? We have 1 here, does not have any s. So this aspect, it is called a constant. Okay, it is called a constant. And when you are differentiate constant, we expect when a differentiated constant is always equal to 0. A number that does not have any variable, does not have any letter, it is called constant. And that constant is always equal to 0 when we are differentiate constant. So it means that we have 0 here. Put that at the back of your brain. When you are differentiate constant, it means that a number like 1 here, it can be like 2. Since that number does not have any s, does not have any letter, so that number is equal to 0 when you are differentiate it. So that is why this is equal to 0. Now let's dive into this. We have our dy, okay, ds is equal to, now we have 4 here, and that is 4, okay, that is 4 minus 1, that gives us 3. So you have s is power of 3, okay, plus, okay, the second one here we have what 4 times 3, that gives us 12, right? So you have 12, okay, s raised to power of 3 minus 1, that is 2. They have s raised to power of 2. Yeah, we have minus, and in this case 2 times 1, that gives us 2. We have s, that is 2 or 2s. Now 1 minus 1, 1 minus 1 where is equal to what? 0. So definitely this one because our s raised to power of 0 here. I get now this 1 minus 1 we get what? 0. S raised to power of 0 here. So let's see this magic. It's not the magic. Let me convince you, it's not the magic. So if you still remember our indices very well, you know that anything that raised to power of 0 is always equal to what? 1. So therefore now our dy, okay, our dy ds is equal to, that is 4 what? S raised to power 3 plus, that is 12 s raised to power 2, and here as minus what? S raised to power of 0 here is equal to 1. That is 1 times 2, that is equal to 2. So the answer is equal to this. So when you differentiate this question, y is equal to 4s, y is equal to s raised to power 4 plus 4s raised to power 3 minus 2s plus 1. The answer is equal to this. This is the solution to this problem. Hope you guys getting it. So if you get to this, if you understand the class, go to the comment section and says you understand it. So let's dive to the question B to get more explaining what I'm about to say. So this question B is almost the same thing as the question A, but let me treat more example and then I will give you classwork. No, I don't joke with the classwork to be submitted immediately, 30 minutes immediately after this class. So let's dive to the question 2. This is question B. Let's solve the question B. So let me try to write it out here. Let me say maybe I can say space here. Okay, there's a space here. So I'm going to try to copy the question here. So the question says that we have y, okay? We have y. So let me bring my pen out. So we have y is equal to, we have that is 6, s is power of 3, okay, minus s is power of what? Of 2, minus, this one is 2, s is power of 2, minus that is 4 is power of 4s plus 1. Okay, so in this aspect now, so we want to solve this question. Let me create space. So we want to solve this question now. Some of the same thing. So I will explain this one in a fastest way. I don't need to expand it the way I did this one at time. So I think by now you should understand how you did. Now let me explain this one in a fastest way. So it just put it in mind that we have to start to differentiate this one to find the y. Okay. So let me print out. To find the y, okay, the y ds, to differentiate this with respect to s. Now what you just have to do here. So what you just have to do here, you need to differentiate this one with respect to what? To s. So it means that this power here, the base here is 6s, right? The power here we multiply by this base. That will be equal to, that is 6, let me say that's 3 multiplied by 6 what? S. And we subtract 1 from the index, the power here, that is 3 minus 1, minus, we have done with this, so let's go to this. So we want to differentiate this one with respect to what? To s. That means that we have 2 here, the 2 multiplied by the base here, that's equal to 2 multiplied by what? By s, and we subtract 1 from this base here, that is for this index rather, that is 2 minus 1, okay, minus, and this place we have the power here is 1, which does not visible, s raised to power s stand alone, but that s is raised to power of 1, which does not, sorry, what's happened? Sorry for this version of that. Sorry for that. I think it's this pen I'll cause it. So in this place now, I will say that this s is principal of 1, okay, which does not visible. What's happened? So I said that this s is principal of 1 which does not visible, right? So that is what I'm indicating as y, as 1. So 1 times 4, that's good as what, that is, you have minus, you have the minus, that is 4, okay? 1 times 4 will still give us that 4, right? And s principal of 1, we saw first one for the base here, for the index here, that's 1 minus 1. I get now plus. In this place, this is a constant which does not have any variable s, does not attach to s. So this is called constant. And I said that when you differentiate constant, it's always equal to 0 because it does not have any variable s or any variable of any letter at all. It's standalone, just a number which does not attach to any letter. So it means that this is equal to what? 0. When you differentiate 1, it's equal to 0. If it is 2, it's equal to 0. It can be any number, it is equal to 0 since it does not have what? S. Now, we have done with that now. So let's quickly solve what we have here. So therefore, our dy, okay, the s is equal to 3 times 6, we have 18, okay. 3 minus 1, that is what, 2. So we have s is power of what? Of 2 minus, and here we have what? We have 2 here. 2 times s, that gives us 2 or 2s, okay. 2 minus 1, that equals s is power of what? Of 1. So it's the same thing. Either you say that 2s, because s it's also raised to power 1 every zero, right? 2s, okay. So in this place then we have minus, okay, they have forward 4s, okay. 1 minus 1, that is equal to 0. So this s here is raised to power of 0 here. So this one has to mean because it's equal to 0. Now I say this, remember this is indices. Anything that raised to power of 0 is always equal to 1. So 1 multiplied by this 4 we get as 4. So therefore now you can say that our dy, okay, ds is equal to, that is 18s with power of 2 minus 2s. So this s, it means that it's raised to power 1. I don't need to indicate as 1. Just know that if you have ordinary s, that s is raised to power of 1. Now we have minus, we have this s is power of 1 is equal to 0 according to the law of this is anything that is power of 0 rather. And let me make that mistake, right? So anything that is power of 0 is always equal to 1. So 1 multiplied by this 4, that's equal as 4. So the answer is to be equal to 4. Now, when you're solving this question, when you're differentiating this question with respect to s, the answer is equal to this. This will be the answer of this problem. And that is how you solve it. I hope you guys understand this class. I hope you guys enjoy this class. So that is the solution and that is how you solve this question. And that is all about the sum of these, that's all about the sum and the different rules under these rules of differentiation. That is everything you should understand about sum and different rules of differentiation. It's quite very simple, right? So guys, if you enjoyed the class, I'm saying that if you are not yet joined our WhatsApp group where you can ask questions if you have any issue with our class, or you want to help you, maybe you want to ask any mathematics question, you can also let us know in that group. So it's a support group. It is free to join, but if you wish to join one-on-one class, you can also request for the VIP class. So let's go to the classwork I have for you. Okay, let's go to the classwork I have for you. So if you look at the question I have now, I have 2 questions for you as classwork. It's very important for you to attend it. That will make me understand. That will make me that you guys understand what I have been taught you since morning. You know that you guys have understood it and you have well understand and understood it, right? So you try the question 1. Okay, it's very simple. You have to differentiate this with respect to s. Okay, this is very simple. Don't be convinced. It's very, very simple. Try your best and submit it for any correction. Okay, and this is why we have the y ds. We have to differentiate this with respect to s. It's almost the same thing what they did in class, right? So if we understand the class, this question here is very simple. This is from y question. This is a y question, and this is also JAMB question, but I don't decide to input the option to it. So I said that if you are just watching a video, you have not yet joined our WhatsApp group. You can contact me on WhatsApp so that I can add you to there. On this number, we have 090, we have 61, we have 22, we have 16, we have 506. Don't call me, just message you on WhatsApp. This number is not for call. Just give me a message on WhatsApp. I will get back to you immediately. I will shout you back immediately. So guys, let's go to the next class where we discuss about the chain rules and on the product word rules. So guys, let's meet in the next class or the next module. Thank you. So let's go.